3.3 homogeneous linear equations with the constant coefficients. You probably notice on Canvas there is no quiz for 3.3. You will have the quiz for 3.4, 3.5. And this 3.3 is basis for 3.4 and 3.5. So homogeneous because right-hand side is equals to 0. Now we're going to change this into am squared plus bm plus c, and we're going to call it auxiliary equation. And you're going to type this into your calculator. Your calculator should give you the answers, just like ax squared plus bx plus c. If this is the case, type the coefficients a, b, and c into your calculator, then it's going to spit it out. x1 equals to -5 and x2 equals 5, something like that. When we have those m1 and m2, if it's the second order differential equation, there's three different cases. Case 1, m1 and m2 are real and distinct. Okay? Then we need to use a y sub c complementary solution as this. If they are the same, real and the same, then the first one is the same. But since m1 and second m1, which is m2, is the same as m1, so we cannot use the same format anymore. So we need to multiply x for the second part of the solution. And m1 and m2, they are complex conjugate. Then we're going to have m equals to alpha plus minus j beta. Then alpha goes to here, beta goes to here, and that's going to be our solution. So let's do this. So we have 2y double prime minus 5y prime minus 3y equals to 0. So now we need to find auxiliary equation 2m squared minus 5m minus 3 equals 0. You need to be careful in here. I know every time some of you confuse and put the m at the very last one. So double prime for the second power, single prime for the first power, no prime for the no m. Take a note on that. So if you have a 3y, you are not going to write 3m. It's just a 3. Now, if you use your calculator, find the roots or solution of this, m1 equals 1 over 2, and m2 is going to be 3. So this is the case 1. They are different. Solution is going to be c1 e to the m1, which is -1 over 2x plus c2 e to the 3x. The second one, our auxiliary equation is m squared minus 10m plus 25 equals to 0. Now in this case, m1 equals to m2, and that is 5. It's going to be m minus 5 times m minus 5 equals to 0. So m equals to 5. And this is the case 2, because 2m values are the same. Then we have to put our solution as c1 e to the 5x plus c2 e to the 5x. No, because we cannot have the same term. So what we need to do, we need to multiply x for the second one. c2 x e to the 5x. Third one, our equation for this problem is m squared plus 4m plus 7 equals to 0. And if you put that into your calculator, then m equals -2 plus minus j square root of 3. The real part is going to be the alpha, and imaginary part will be beta. The solution for this case, y equals to e to the alpha x c1 cosine plus c2 sine. Then we have e the -2x c1 cosine square root of 3x plus c2 sine square root of 3x. So when we solve a higher order differential equation, we need to find the Aux equation first, and that Aux equation is going to give us one of those three scenarios. The first, roots are all different, then you need to put e to the ax c1 plus c2 e to the bx they're different. Second, if they're the same, then we don't want to use the same E. So C1AX plus C2X E to the AX. If the oxy equation is third order differential equation and they're all the same, then C1 e to the AX plus C2 x e to the ax. The third one is going to be C3 x squared e to the ax. And the third case, if they are complex number, then we need to use, let's do this. So for this, the oxy equation, m squared minus 36 equals to 0. I'm going to repeat that again. You don't want to write m here. Double prime for the square, no prime, no m. Then m squared equals to 36, m equals -6, and m equals to +6. They are different. Therefore, the solution is going to be C1 e to the -6x plus C2 e to the +6x. And 3.3.18 is going to be the same. They are all different. So you're going to say C1 e to the -2x, C2 +2x, C3 e to the -3x. They're all different. So you're going to have that. It's very straightforward. So for this, instead of your given prime, we have d over dt. And we can just put that into the prime form. That is y triple prime minus y double prime minus 4 equals to 0. Well, it's an x, so I mean, you can say, hey, Dr. Kim, it's an x. Should we do this? Yeah. And our ox equation minus m squared minus 4 equals to 0. Again, no m for the last term. Then we're going to have m1 equals to 2 and m2 and 3 equals 1 over 2 plus minus j square root of 7 over 2. How we go from here to here? Using your calculator. Then it's going to be alpha and beta for the m2 and m3. And the first one is E. So from here, we have y equals C1e to the 2t plus E alpha -1 over 2 t C2 cosine square root of 7 over 2 t plus C3 sine square root of 7 over 2 t